Okay, hello student. Here I am. This is the video I would like to make quickly. Just few problems that I'm going to help as a study guide so that uh, you could complete your quiz number 4. Okay, so similar type of problems I walk through to help you to recall the concepts. And this is module 4. Okay, I'm gonna straight away solve one of the example. Let's do the first one. Factor the expression completely. So you can see this. If you see this three, it's a trinomial, and clearly there's a x which is like a common factor. So if this is the one, you can directly write this on your notebook so that you can understand. So you're going to divide by, there's an x here, so divide by x, divide by x, divide by x. And you can't just divide by x, you have to multiply by x. So the x stays outside, and this x square will cross out. There will be two of them remaining, and then here one of them will go away, and you'll be getting 2x plus this both x crosses out, and you get 1. Now you have a quadratic, right? So two ways you can think of either when you look at it, it may not be a perfect trinomial. Maybe you just want there's a 1 here, and the only option we can split this 1 is 1 times 1 is 1. 1 times 1 is 1. That's the only option, two factors we get. And 1 plus 1 adds to 2. So we can write this uh, quadratic into two binomials, two factors. And there's a 1 here, so it becomes easy. And just put x right here. And because the factors are 1 and 1, and they have to be, remember 1 times 1 is 1, and it is plus 1. So both have to be minus minus, or both has to be plus 1 and plus 1. So we will take it plus 1 and plus 1 because there is a plus 2. And you are done. That's the complete uh, factorization, which is this is a cubic with a degree 2, and that is, and you can see by just looking at it, this is like x minus 0, x plus 1, this is factor form, and the x plus 1 is repeated twice, so there's a multiplicity, so that means there is a opposite of here, one of the 0, that means when is this going to be 0 is when x is 0, and also when x equals minus 1 because there's a plus 1, but it is a repetition, right? So there's a multiplicity 2, so that means that if I write this as minus 1, this is 0. So the graph of uh, the the cubic polynomial that is given is there's a plus 1, so it has to be something like this. And because there's a multiplicity at minus 1, so here it starts from down and then takes a turn somewhere. We don't know where. Maybe like this, maybe this way, but then eventually it has to go through 0, and that's how it is. Okay, let me go to the second. Let me do another problem. Now, in this case, you see there's a x plus 1, there is x plus 1, there's x plus 1, but here there are two of them. See, so one of those, so what is x minus 1? Square is x minus 1, and there's another x minus. So one of them we can pull out, so we can factorize it. That means we need to write something here, and then I'll put a parenthesis to show that this thing is 1 and this thing is 2. So one of them is outside, can be taken. And also there's I can use the black color for this is x plus 5, which is 1, and there is 2 here. Same thing, right? So we can pull out this x plus 5. This factor can be undo the distributive property. So when the blue one is taken, when the blue one x plus 1 is, sorry, x minus 1, that's x minus 1. I made a mistake there. So x minus, then, so this is completely gone outside, right? It's taken off. And this x plus 5 also is taken off. So what is remaining is from x plus 5, one of them is out. So x plus 5 is remaining, right? Now this by default minus will remain right here. And then there is 2x minus 1 here. One of the x minus 1 is already taken off. So the one remaining x minus 1. This is where you have to be very careful. So this will be x minus 1 and x plus 5. And what remaining is this x plus 5 stays the same, and use the negative property. That means you are distributing minus 1 inside and get minus x and plus 1. This x goes away, and all you get is x minus 1, and 5 plus 1 is 6, and that is 6, or you can write this 6 is written in the beginning. Okay, so there's another question is find all the reals. So I'm doing the third example. This is a quadratic. You have so many different methods we can use. So the one that I showed in the class, I'll do that. So 6 times 7 is, so remember we need to write, if it is x square and something like this bx plus c, then you could just write xx. But then remember, if it is ax square plus bx plus c, better write ax ax here, that's the trick, and divide by a. So in this case, it is 6x squared, so you write 6x, and then again 6x, and then divide by 6. Okay, now multiply 6 and minus 7 gives you minus 42. So what are the factors? Remember, there's a minus. When you multiply, one of them has to be plus, the other one has to be minus. Now, the factors of 42 is, we can write 1 times 42 is 42, and 2 times 21 also is 42. And I want to write, of course, I'm just keeping the sign, and you can say 3 also divides, and 3 goes 1 time, and you got 14 times. And you can clearly see there is that one of them has to be plus, and because you, so that means you have to subtract. And when you subtract, you want to make sure there's a plus 11 right here. And you can see this is the only option that will help us. You take away 3 from 14 is 11. So the best is, because there is a plus sign, you're going to use the minus 3, and plus 14 is plus 11, and minus 3 times 14 will yield you for minus. So this is the better option. So these are the two answers. You just write those numbers, plus 3, and the other one is 14. Once you get this, somehow you have to get away with the denominator. Say, I split this 6 into 3 times 2. So why did I do this? That's because you can divide this 3 divides 6 2 times. This 3 divides this 3 1 time. And then the first parenthesis will be 2x plus 1. And in the second one, this 2 divides this one 3 times. And 14 divides 7 times. So what I left with 3x plus 7. So the question is asking is we need to find. So somehow we got away with this 6, right? And then you use the zero product property. And what is zero product property? Either this thing is 0, okay, or the second one 3x plus 7, or you can directly write it. What is that? X equals opposite of plus 1 is minus 1, and there is a multiplication 2 divided by 2. That's it. And here x equals opposite of plus 7 is minus 7, and there is a multiply by 3, so divide. And these are the two answers you're done. Let me do another problem. So as I say, I just wanted to solve an almost like 11 problems that could help you to do your quiz number 4 in Model 4. So again, sometimes they ask us a question, something like this, find the real solution of this, and you can see there's a square is b. It means your a is plus minus square root of b. So that's all you're using here. So you get your upper a, this is like your a, and this is your b. So a is, that is x minus 3 is plus minus square root of b, which is 2. So your x becomes minus 3 equals plus, okay, I'm just writing the same step, and you add 3 and plus 3, and then you get x equals 3 plus minus square root of 2. And your answer is, one of the answers is with the plus sign, and the other one is with the minus sign, 3 minus root 2. And it depends on whether they want you to write exact values, or sometimes they may ask you, hey, use the calculator and write this into 2-place decimal. So if they ask you to place decimal, you better. So this square root of this is 1.41. This one is, and you can do this way also 1.41, and then this becomes 4.41 and other. So that way also, if we subtract 3.00 and 0.41, and you can see this is 2.5. So it depends on what kind of question is asked, and you can figure out. So let's do another problem. So this is asking you find the solution of the equation. You can see this is like you have a kind of a cubic function, parent graphs of a cubic function. There's something like this maybe. And there is a 4 to the right side. So there are two functions. One is x cubed and the other one is like 4x. And you want to see where do they meet? And then this is the graph. And the 4x, maybe 4x is something like this, like this. So this is not a perfect. Maybe it's cut in two places like this. So you want to know where do they meet. So is the sketch important? No, you're just solving by manually. So if this is the case, the first thing is you subtract 4x both sides so that the right side is 0. And then you can see there is a x which is a common factor, or it's like you're dividing by x and also multiplying by x. So that way you get x is x squared minus 4 equals 0. And you can use the difference of square formula, which is a squared minus b squared is a plus b and a minus b. So this whole thing can be written as this 4 we can write as x squared minus 2 squared equals 0. So now you know a is, so this is your a and b is 2. So your final answer is x, and then a plus b, that is x plus 2, and then a minus b, that is x minus 2 equals 0. And then the question is find all the real solutions. The answer here is so this x which is there, this x is basically is like x minus 0, right? So there are three. So instead of x, you can just write, instead of x, I'm going to write this as the reason is okay, x minus 0. So there are three parentheses or factor forms. What are the zeros here? So the zeros means when is the left becomes equal to 0, each one of them has to be 0. So for either first one is 0, x is 0, or this has to be the opposite of plus 2, which is minus 2, and opposite of minus 2 is plus 2, and that's all the real solution in your math. Done. So that means they meet at this point and they also meet at 2. That means this is 2 somewhere here. And if you put 2, it is becomes like 8 because 2 times 4 is 8. So it is 2 and 8. And on the down somewhere here, they meet at minus 2. And this is not a perfect sketch. Let's just show that when it is minus 2, put here, it becomes minus 8. Okay, let me do another problem based on this. Okay, so sometimes you may be given a question, find all the solution of the equation x, express them in the form of a plus b. It looks like the moment they give you this, it means it looks like these are complex solution, complex roots. So how do we know really this is it is going to be a plus bi? And you can see there's a 82, there's a 1 here. So the question is, can we do this way x plus n? So what are the numbers that go here? So that's how we figure out. So if you see there's a 82 plus 82, what are the factors of 82? 1 times 82 is 82. And also 2 times 41 also is 82. But then none of them add up. This 2 and this adds, you need to make sure they add up to 18. Do they add up? 41 plus 2 is 43. And this is not equal to 18. And this two become adding up will be 83. So none of them work. So naturally this shows that you can't do this. So that's not possible. So that means what are our options? So if this doesn't work, so does it have a real root? So what is the best bet to do this? There are two ways you can think of. Maybe you want to think of a quadratic formula, and you may thinking, okay, let me use this minus b plus or minus b square minus 4ac and all that. Or you may be thinking of what about completing the square method? Which one is the easy one, completing the square method? So if you work this out, then opposite of plus 18 is minus 18 because there's a minus here. So plus, and then you have to do 18 square, a lot of work, see? And then a1 and then c, which is 82, and then divide by this b is 18 here, sorry, and then 2 times. So that's too much of work. So we'll skip this. And so instead of this, we'll try to use completing the square. We'll use, what is this completing the square method is? Very easy. You've been doing this from algebra 1. So what I'll do is subtract 82 both sides. And when you do this, you get x squared plus 18x is minus 8. And then you think of getting the left side. You want to add something here. And when you add this, you have to add also to the right side. What is that you're going to add? Is to make a perfect trinomial. So how do you make a perfect trinomial? Is always half of the coefficient of x and square. Now here this is 18, right? So you'll write 18 and take half of this, and if you square 9 square, then you get 81. That's all you're supposed to write both sides. This is 81, this is 81, and this also is 81, right? That means the left side now is a perfect, this is a perfect trinomial. It means it is like this. See? It is 9 square. You want to really compare with the a square plus 2ab plus b square, and this is a plus b the whole square. You can see this is x square. 18 can be split as 2, and then put an x and then a 9, and look exactly like that. And this is together is minus 1. Now, this is so what is A and B here is A and this is B. This step is not needed. We could just skip this both steps. You could skip this step and write directly from here and say, hey, come on, we are college bound students. Why do you even care about that? And you just say A is X, so X, and this is 9 because you put 81, which is 9, right? So X plus 9, the whole square is minus 1. See this part? Now I don't have a room at the bottom to write. I'll go up there. I'm going to copy this up. X plus 9 the whole square. So you get x plus 9 the whole square is minus 1. And then the base, which is x plus 9, is plus minus square root of minus 1. But by definition of imaginary unit, we know that square root of minus 1 is I. Imaginary unit start with the letter I. So it is I. So this thing will become x plus 9 is plus or minus I, and then subtract 9 on both the side. So subtracting 9 minus 9, okay, minus 9, and you get this goes away, you get x equals minus 9 plus minus I, and the two answers are x is minus 9 plus I, and the other one is x minus 9 and minus. You want to make sure when you put in the box. So sometimes the homework is make sure you put this thing right here and then put a comma and you get the correct answer. So let's see what was the question. This was the question, right? So what does basically this means is it is x. So this part it means there is a if you sketch it means the graph, it is a quadratic function, something like this, but it is above something like this. So it does not cross the x-axis. So they don't have a real, it's not this way or this way. There's no, nowhere on the x-axis the graph crosses. So there's no real zeros, but they have to say they are complex solution, these are called complex solutions. Again, here find the real solution. We don't know how many real, how many complex, but one thing I know, there's a cubic, there's a degree, which is 3, and there is also kind of y-intercept. Let's say this is 18, and because this is plus here, it is down, up, and maybe going through this also. So we don't know. We want to know where does it go? Is it something like this and goes like this and goes? And we want to figure out this. And you can also use Descartes' rule also. You can say how many positive, negative. So if I go from here, the sign changes plus to minus. Here it doesn't change, it minus minus, but here it changes. So there are two positives, 100%. There are two positive zeros here. So let's check that out. So you can use the grouping method and try to factorize. So let's put this 2 and see what's going on here. What is common here? You can see x squared, we can divide here x squared, divide x squared. So when you do this, you have to also multiply x squared. So that means it is x squared, and what stays here is this x squared goes away, and one x will remain. This x squared goes away, and then 9 x minus 9. And in this case, you're going to see you divide by 2, and you just cannot divide by 2, but you'll have to also multiply by 2. Now, there's a confusion here. I want to make sure When you put a parenthesis, remember when you put a parenthesis and there's a minus outside, this plus sign will change to minus. So you need to be very careful there. So if I write minus, so you pull out -2, what stays is this 2 goes away, get x and -9. So this plus sign changes to minus. And you can check also, if you multiply this, let me take all this off. So if you multiply, it's just undoing the distributive property. Watch this. So if I use the distributive property here, -2 and x is -2 and -2 and -9 is +8. So all we are working on is doing the undo the distributive property. Now the next is, you notice that there is a x minus 9 right here. So it means this is the factor which is common for both, right? So I'm going to pull this x minus 9 outside, and what stays inside is this x square will remain, and this side is a -2, which is, oh, that's too much, that's too big. Let me put it small there. So it is x squared, and this -2 will remain, right? So because you pulled out the x minus 1, this is like a common multiple for both the terms. So this is that x minus 9 I pulled out. Now what I'll do is I'm going to write this up here. Whatever I have, I'm going to write up x minus 9. So x minus 9, and the other one was x squared minus 2 equals 0. So now what do we do next is you say, okay, when is this going to be 0? How do we get either the first part is 0? You say, so either the first parenthesis 0. If that's not the case, then the second parenthesis at least has to be 0. You solve for this, and you get x equals 9. That's the first time. The second one, you add +2, and you get x squared is 2. And then you can use the square root. Taking the square root, that means x is straight away plus minus square root of 2. So there are two answers, -√2, and the other one is +√2. It means there are two answers. One is -1.41, blah, blah, blah. And this is like, again, plus 1.4. Of course, you're not supposed to sketch, but let's sketch it. So what it means is the graph is like this. That means it goes through +9, and also it goes to plus 1.4. Let's say this is 9, this is 1, and maybe 1 point is somewhere here. This is 1, this is like 1 to square root of 2, which is 1. This is square root of 2, which is 1.4. So it goes to this, it goes to this, the somewhere 18 up here, the somewhere 18, and -2 somewhere here maybe. And the graph wanted to show, even though they did not have, maybe it goes this way, goes down, and goes like this. Hope that it's a cubic, like degree. It has a maximum solution is 3. So these are the 3 real zeros, and we're done. So 2 positive, 1 negative, and you can see that there's Cartesian rule we can use to see how many positive and negative. Clearly, this one has so this is another problem. I'm doing problem number 8, and there's a 4. So that means degree is 4. What does this degree is 4 mean? That means your graph could be at maximum it can go is 4 places, 1, 2, 3, 4, or it also could be doesn't even cross like this. See, 4 complex zeros also, or it can cross twice. It can cross twice this way and just touch this and go. That means this could be a point which is with multiplicity 2. So there are 2 here, 3 zeros, but one of them is repeated. So it could have like this also, or it could have this way also. So 2 zeros with multiplicity 2, right? So this kind of problem, all you do is you can write this as let's reduce it to quadratic form. So x raised to 4, what I did is the x, right? So it means there are 4 of them. So this is x squared, this also is x squared. So it is x squared, and that's how I wrote this step. Now what do we do next is let's replace x squared by some other variable p. So this will be p squared minus 8p plus 7, and you're back to your early. How do we factorize this? So how do we break this 7? It is plus, right? The only option is 1 times 7 is 7. And because this is p squared, you put a p and a p there, and 1 and 7. But do I put plus 1 and plus 7? But that way, plus 1 and plus 7 will add up to plus 8. But we have a minus. So you see there's a minus 8 here. So this has to be both minus. So you can't have this. So this is wrong. So it has to be minus 1 and minus 7 adds up to minus 8. So you have to use minus 1 and minus 8. Okay, I don't have enough room. So what I'll do, I'll go back up here. Hmm. So p minus 1 and p minus, I forgot, 8, right? Equals 0. And then you can say directly, you can say the opposite of minus 1 is plus 1. So it's like asking a question, when do you think this is going to be 0? The only option it has to be 1 minus 1 is 0 or 8 minus 8 is 0. So you know that p is 1 and p is 8. So this is p is 8. But then replace back, what is p? Remember it was x squared. So you write x squared is 1. So p is x squared. You put it back. Then you write down here and take the square root both sides. So this is x equals plus minus square root of 1. And this means it is x square root of 1 is 1. And the other side you write plus minus square root of 8, which you can still reduce it to, because square root of 8 you can write as 4 times 2. And this means square root of 4 and square root of 2. And square root of 4 is 2 root 2. So because they expect you to have the exact value, so this is 2 root 2. So here you have two answers, and here you have another two answers. Together, four answers. So that means how to write? What are the four values? So the four answers are, one of the answers is here, plus 1 and minus 1. So it is plus 1, minus 1. And from here we write minus 2 root 2 and plus 2 root 2, and you're done. Okay, I think I made a mistake at the bottom here. When I say this should have been, there is one mistake I did see, that this one, 7, this 7. So I should have written down this 7. So this should have been minus 7. I'm sorry about it, but as long as you understand, it's important. So that way, when you go back, this will be your. So all I made a mistake here. So I wanted to rectify that. So it's going to be 7, right? So opposite of minus 7 is plus 7. And you take the square root of that plus minus square root of 7. So two answers will be, so you don't, of course, I try to show this just in case you had to, if you had to have 8, then that's how you would do it. But right now, it's just a square root of 7. So you don't keep it like that. So it's minus square root of 7 and plus square root of 7, and you're done. Okay, let's see another problem. I think it's problem example number 9. I forgot which one I'm working on. Solve the equation and check your solutions. Okay, here it is x minus 1, 3 by 2. Let me write it raised to 3 over 2, and that is 27, right? So because there's a denominator is 2, so what I'll do is square both sides. I don't want that a denominator. So if I square both sides, but the main thing, we need to have this x minus 1, right? So you don't want that 3 by 2. So what is the reciprocal of 3 by 2 is 2 by 3. So you do multiply both sides. So this one, you raise to the power, do the opposite. So 2 by 3, and this also is 2 by 3. And when you do this, this goes away and you get x minus 1. And what is this means? What does this mean? Basically mean it's the cube root of 27, or you can also think it like 27, you can write is 3 raised to 3. And the outside is 2 by 3, correct? Which is which is x minus 1, which is 3. And this power of power formula, you can use 2/3, and this 3 goes away, you get 3 square, which is 9. And so x minus 1 is 9, so I don't have enough room here, so let me write this whole thing on top. So you get x minus 1 is 9, and you add 1 to it, and you get x equals 10, and you are done. Now the problem is, what's happening here is, why there's only one answer? Uh, because watch this. So this time you see there's a 2 here. So x minus 1, all you do is, this is 3 by 2. So we are multiplying, we are trying to raise to the power. Both sides we are trying to raise to the power, and that is 2 by 3. And this 3 is very important. It's like you're taking a cube root. So if I take this, it's like you're taking cube root of like this thing. So it is like cube root of this. So very careful you have to be. Uh, Let me show one more time. So what I'm doing is this, I'm multiplying by 2 by 3, and this also I'm multiplying by 2 by 3, right? So there's a cube, so it's like a cube root. It's like a cube root of x minus 1 uh, raised to 3 by 2 and square. See, there's also a square there, so that's what that means. But don't worry about it. Just check the right side. This means it is 27, and this 3 can be written as cube root of, and there's a 2 there. So when it is cube root, doesn't matter what you have inside here. So it's going to be only one answer. So what I'm trying to say is, this thing can be more understood with the help of actual graph. What's happening is, if you see, is what is the meaning of uh, if I ask you how do we graph x raised to 3 by 2? What is this actually? It is y equals x 1.5, and you see this is x raised to 3 by 2. There's a 2 there. So because there's a down is 2, it can be written as y is uh, it is a square root of x cube. See? So in other words, the inside the radicand, this radicand has to be always positive, right? So it has to be always. I mean, when you have a graph like this, I mean, you are thinking of only those values which are the domain is only positive. So that means, because it is a square root and this is a 2, right? So that's the 2 right there. I know this is, you could do directly. I'm just showing this the conceptual understanding of how what's happening here is. So the graph of this is a power function also, is something like this. So it goes something like this, and you're asking, when is this going to be 27? So there will be 127 here. So there will be 27 right here. So a line, what is y equals 27? So it's a constant function y parallel to the x-axis here. So if this is 27, so it has to cross somewhere, and that is 10. So when it is 10, and the answer is 27, and that's the understanding of. I hope making sense. Even the problem is very simple. I thought of showing you the graphical representation. How does that work? That's what that is means. Yeah, as I said, I'm ending this study guide. As I said, this is a study guide for you guys to complete quiz number 4, module 4. I hope I made sense to you. And again, I want to repeat, remember this part. Uh, what I wanted to say is, if I have an x square, remember the parent function x square, it is a parabola. It's a parabola concave up, opens up like this. That's a parabola. If I have x cube, and that is something like, uh, and this is that's the cubic function, right? If I have x raised to 4, then it goes this way. Not like this. That is, here it goes this way, but here little flattens here. Okay, the point I'm making is, this is 2 and this is 3, and in between what's happening is I'm asking what is x 1.5, right? So that's between 2 and 3 is 1.5. So I'm asking what is y equals. So that's why I was saying this. It goes something like that. Okay, it goes something like that because the domain of this is only the positive. So it goes this way. I hope I'm making sense. It's so beautiful to understand the concepts here. So with this, I end up my video.